we will now come to velocity diagram of example 2.2. Here we are supposed to find out the velocities of the slider, of the offset point, point E, and also the we have to find out one point on the connecting rod such that the velocity on that point will be a minimum. Okay, we have named that this point is called F, since we have to find out the position of this on the link AB is not given to us. Alright, what is additionally given to us is the lengths of the links. The crank length OA is 480 millimeters or 0.48 meters. The connecting rod AB is given to be 1600 millimeters. Okay, and the angle the crank makes, or the instantaneous angle which we have to consider in this case, is given to be 60 degrees. Okay, now what we do is, once angular velocity is provided, we find out the linear velocity using the angular velocity times the radius of rotation, in which case AO, that will be velocity vector of AO will be omega AO times AO, that is 20 times 0.480, that will be 9.6 meters per second. Okay, so now what we are going to do is, we will first identify in which direction the crank is moving. The crank is moving towards the anti-clockwise direction, so it makes sense if I put A and G to the right of the paper, because if I put it on the left, now the velocity diagram on the vector A, it will also go to the left and we will not have any space left. Okay, so you will please organize such that you will be able to draw the entire velocity diagram on the same page. So now what we will be doing is, we find out the points which are fixed, in which case it is O and G. So make a point O and G. Okay, these are fixed points on the velocity diagram. Now what we do is, we take a line and draw a perpendicular to the line OA. Okay, and draw a line perpendicular to the line OA. Right, now when we have finished, let me take this a bit down. I have drawn a line. This line is perpendicular to OA. Let me write this: perpendicular to OA. Right, so in which case this point will be A. Right, now this line is velocity vector AO times the scale that you have chosen. Scale that you have chosen to draw the velocity diagram. Okay, now we have come from O to A, and what we should now do is, we should now select the point G. We know that the link B, the sliding link B, will always have a linear motion, or in this case a horizontal motion. Okay, so the velocity vector is horizontal. So from point G, we draw a line horizontal. Okay, and this represents the velocity of the slider link. Since the slider link is going this direction, we will make this to go in this direction. Okay, now if you do not know the direction, just keep it as it is, don't indicate anything. Now we'll see, we will come to point A. From point A, draw a line perpendicular to AB. Okay, draw a line perpendicular to AB. It meets here, so this point should be B. Right, so in which case this is vector BO times S. Okay, now, and additionally this this vector AB, vector BA, this is vector BA. Okay, So now you will have vector BA is found out. We know that once we find out the value of VBA, we can calculate the value of B with respect to O, or what we can do is we find out this particular length, okay, and first let us write, okay, parallel, or this is horizontal, okay, so or now what should be done is this is perpendicular to AB, right? This is minus S. So now let us proceed to find out the velocity of the intermediate point. Now the answer for this is VB. You measure this distance, VB is B to O divided by the scale that you have selected, okay, the scale that you have selected, in which case it is VB over times S by S. This looks confusing, just look at this, okay. Find out the length OB in your velocity diagram, okay, and divide that by the scale that you have selected. If you have chosen a 1:1, that itself is the value of VB, right? Then let's say that you got the velocity of VA about to be 10 meters per second, and you have drawn on your this thing as 50 millimeters, then the scale will be half, right? So now we'll proceed further to find out the velocity of, or the point of minimum velocity, okay. And now what we should do for that is we find out from the point F is to be lying on the link AB. So on the velocity diagram, the velocity of point F should also lie on this line, right? So it has been given that we have to find out the point F such that its velocity is to be minimum. So the only line which connects from point O to AB having the least distance is the perpendicular from O, okay. So what we do is we draw a perpendicular to AB from O, right? So this is this, right? This point is F. This vector represents vector FO times scale. Yes. So now we have to additionally find out the value of velocities at A. So now what we do is we similarly for F we similarly have to find out the length, okay, divided by the scale that you have selected. That will give you the value of the velocity of point F. Now that you know the value of position of F on the line AB, so what you have to do is you have to apply a relationship. That relationship is to find F position on AB, okay. So now if you look at this closely, AF by AB is AF by AB, okay. So in which case AF can be easily known. What you have to do is you measure this distance and you measure this distance, okay. That is AF, AB is this distance, therefore AF is AF by AB into AB. Okay, this is AF is known from the velocity diagram. Okay, AB is also known from the velocity diagram. AB is known from the given data. Okay, therefore you can calculate what is AF. AF is the position of the point F on the link AB from A. Now let us proceed further to find out the velocity of the offset point E. So to do that, it is quite simple. All we have to do is find out the proportions or the ratios. What we do is, let me write it here. We write AE. E has to lie on this point. Okay, somewhere. E has to lie on this point somewhere. Okay, so for that what we do is, let that point E be somewhere, okay, outside, okay, that you don't know, okay, you don't know, let that point be E, okay. So now you have something to refer to, right? Now geometrically, EA, take the value of EA, okay, divide that by AB. Okay, so now that should be velocity magnitude of the velocity of EA by AB will be magnitude of vector EA divided by the magnitude of the vector BA. Okay, so now here you know the value of EA because EA is given to be 0.45 meters, right? Since the value of position of E is given to us, we can find out what is vector VEA because EA is known, BA is also known, okay? In which case it is 1.6 meters, and velocity vector BA is also known. Therefore, VEA is going to be VBA into EA by BA, right? So now what we have to do is, we know this value, you measure this particular, if it is not here, you measure it, right, and then write it, okay, that is your point E. So now if you want to find out the absolute velocity of point E with respect to O, join, this gives you the velocity of E with respect to A times scale. To find out the velocity vector, you have to find out the length of EA on the EO on the velocity EO on the velocity vector, and then divide that by the scale that you have selected. Okay.